St. Joseph's College for Women Autonomous Visakhapatnam, Department of Mathematics welcomes you for the online course on linear algebra. In this linear algebra, this section is inner product spaces. My name is Dr. V. Gauri Shankar Rao, Assistant Professor in the Department of Mathematics, St. Joseph's College for Women. Let us see in this section we can discuss inequalities in inner product spaces. The study of inequalities in inner product spaces help us to measure, compare and estimate vectors and their relationships. So let us see this how to understand the role of inequalities in analyzing vector space and bounding quantities. So understanding inequalities, analyzing vector spaces. So they provide upper and lower bounds for norms, inner products and distances. So let us see this the second point. Develop the ability to state and prove fundamental inequalities such as quasi-squares and triangular inequalities. Let us see this quasi-triangular. Once you can product x comma y, you can apply the normalized less than or equal to individual normalizes. Then triangular inequalities. Let us see this. The third one is interpreted inequalities in terms of geometry. It means length, angle, distance and inner product spaces. It means it is a cos theta. So modulus x equal to norm x into the product of two vectors. It means the fourth one is apply inequalities to estimate norms, distance and inner products. It is estimate of distances. It is a norms. The fifth one is analyze the conditions for equality in key inequalities and their implications. It is like inner linear dependence. It means it is a quasi-squares. So let us see this sixth one. Use inequalities to establish important properties of vectors and spaces including stability and bounds. So by using parallelogram law, that provides relation between norms and ensures stability. How the vectors and stability, it is very useful in civil engineering. The connect inequalities with practical competitions including projections and approximations. Once you take the projections, three-dimensional object, you can calculate the area, you can convert it in two-dimensional object. It is like in vector calculus. It is very useful. Use least squares and signal approximations and numerical analysis. Let us see this eighth one. Strengthen problem solving skills using inequalities in theoretical proofs and numerical problems. Essential in proofs, estimation of errors and bounding solutions widely used in engineering, physics and data sciences and optimization. So inequalities are powerful tools that helps us compare, bound and understand vectors better in both theory and real life applications. Let us see this engineering and signal processing, data science, economics and physics. Let us see the two very important definitions. Norm or length of a vector in an inner product space. So let V be an inner product space. If alpha belongs to V, then the norm or the length of vector alpha written as normalized alpha. So this symbol is treated as like normalized and is defined as a positive square root of inner product of alpha comma alpha. That is norm alpha equal root over inner product of alpha comma alpha. It means actually the norm means what is that root over first term whole square plus second term whole square plus third term whole square. Now the same pattern here also you can take norm alpha equal to root over inner product of alpha comma alpha. It means let us see this unit vector. Every unit vector the value equal to 1. Let V be an inner product space if alpha belongs to V. So V must and should is inner product. Why? Because of once it is inner product, they compulsory they satisfy the four properties. One is a symmetry property and linear property. Okay, the positivity and alpha comma alpha inner product equal to 0. If alpha belongs to V such that norm alpha equal to 1, then alpha is called unit vector. This is an inner product space. A vector is called as a unit vector if its length is 1. Unit means it is a 1. So always the norm alpha equal to 1, it is treated as like unit vector. So let us see one theorem. In an inner product space. Prove that the first condition is norm alpha greater than or equal to 0. It means the positive, and norm alpha equal to 0 if and only if alpha equal to 0. The second condition, norm A alpha, A treated as like some constant modulus A into norm alpha, where 0 comma A belongs to F and 0 vector comma alpha belongs to V. So what they said, each and everything, it is a inner product space V. So let us see this, the first one, norm alpha. Norm alpha means what is the root over inner product of alpha comma alpha. So I can apply the both square on both sides. The left side is norm alpha square equal to the right side square root is a cancel, inner product of alpha comma alpha. So inner product of alpha comma alpha, it means what is that? Positive value. So by the property, it is a positive value. So that's why norm alpha square greater than or equal to 0. So it means norm alpha greater than or equal to 0. So also inner product of alpha comma equal to 0 once alpha equal to 0. Once you can take alpha equal to 0, automatically norm alpha square also 0. Norm alpha square is equal to 0, then alpha norm alpha also 0. So then if and only property also satisfies. The simply once you can take alpha equal to 0, the product always 0. So let us see this, the second one, norm A alpha whole square equal to. So how we can write inner product of A alpha comma A alpha. So once you can take A is outside of the inner product, then you can write alpha comma A alpha. So once you can write it is a property A, can I write conjugate A into A bar inner product of alpha comma alpha, A into A bar can I write modulus A square, it is like inner product norm alpha square. Once you can apply this property, automatically that can be written as modulus A into inner product of alpha. So norm alpha. So here you can observe this one more note point, alpha by norm alpha is a unit vector. So unit vector means always it is the 1 by norm alpha square into alpha square, the ones the both are these the cancel, that value equal to 1. Let us see this one small problem. If alpha equal to inner product 2 1 comma 2 in a vector in V3 of R with standard inner product, then find unit vector alpha. So standard inner product, then find unit alpha means already alpha is given. What is that? 2 1 2 is given. Once you can apply norm alpha square. Norm alpha square means what is the product alpha comma alpha. So actually norm means root over, but square is, once you can take square, the root square is a cancel. So it means inner product alpha comma alpha. That simply you can product first and first, second and second, and third and third. So once you can add all the terms, you got 9. So it means norm alpha square, then square, and 9 it can be written as 3 square. It means norm alpha equal to 3. So once the product, then find unit vector. Unit vector means what is that? Alpha by norm, given vector by normalized unit vector, normalized vector. They simply norm vector already you have that 1 by 3. So alpha means 2 1 2. They simply 3 you can say that 2 by 3 and 1 by 3 2 by 3. It is like is a unit vector. They simply in vector calculus unit vector means what is that? Given vector by norm vector. The same method. Alpha not equal to 0. So once alpha not equal to 0, it means it is a positive, norm alpha greater than 0. So once I can apply that 1 by norm alpha square, it one also greater than 0. So here I can introduce one gamma. Gamma means beta minus inner product beta comma alpha by norm alpha square into alpha. So now we can apply the two gammas, inner product of gamma comma gamma. You can take the both values, then you can apply the multiplication. Let us see this, the triangular inequalities. Triangular inequality. In an inner product space V of F, prove that norm alpha plus beta less than or equal to norm alpha plus norm beta. It is a simple, it is look like as a additional property. So now you can consider norm alpha plus beta whole square equal to alpha plus beta comma alpha plus beta. Why? Because of this is a property, inner product of alpha comma alpha equal to norm alpha square. Once you can apply this property, let us see this norm alpha square plus inner product of alpha comma beta. So this beta comma alpha, it can be written as conjugate plus norm beta square. It can be written as, let us see this, z plus z bar. Z means complex numbers plus the conjugate complex equal to 2 into real number of z. So by using this property, you can written as alpha comma beta inner product plus conjugate alpha comma beta. It can be written as 2 into real number of alpha comma beta, real part of. So This one it can be written as less than or equal to norm alpha square plus 2 modulus of inner product alpha comma beta plus norm beta square. So this inner product of alpha comma beta, so this one also the squartz inequality property, norm alpha into norm beta. The simply middle part it can be written as 2 into norm alpha into norm beta. So it is look like a square plus 2ab plus b square. It means a plus b whole square formula. So what you can consider norm alpha beta whole square, you can consider you got norm alpha plus norm beta whole square. The both squares is a cancel, you got norm alpha plus beta less than or equal to norm alpha plus norm beta. So for all alpha comma beta belongs to V. Let us see this geometric interpretation. Geometric interpretation. Let alpha comma beta be two vectors in an inner product space. Here what they can say, you can assume alpha beta is the two vectors in inner product space. V3 of R. Let us see this here, the three elements should be written with the standard inner product defined on it. Once the standard inner product means the all properties should be satisfied. Suppose alpha comma beta represents the sides AB bar and BC. It means line AB line and BC respective of triangle ABC. So therefore norm alpha equal to AB, norm beta equal to BC. So also the vector alpha plus beta represents the side AC of the triangle ABC and norm alpha plus beta equal to AC. From the triangle inequality we have norm alpha plus beta less than or equal to norm alpha plus beta. It means AC less than or equal to AB plus BC. It is look like so it is like a equal triangle. So equal triangle means here you can consider norm alpha plus beta less than or equal to norm alpha plus beta. It is like geometric interpretation. Let us see this one more important parallelogram law. The inner product space V of f prove that norm alpha plus beta whole square plus norm alpha minus beta whole square equal to 2 into norm alpha square plus norm beta square for alpha comma beta belongs to V. It will look like as a plus b whole square plus a minus b whole square. So it means, so let us see this proof. Alpha beta norm whole square equal to, how we can write norm whole square means norm alpha square equal to inner product of alpha comma alpha. By using this property here, alpha means alpha plus beta, inner product of alpha plus beta. So let us see this, the first term alpha into the second term total. So next one is beta into the second term total. It means after that again you can multiply alpha into alpha plus alpha into beta. Here also the same beta alpha and beta into beta. So alpha into alpha means what is that? Norm alpha square. So again, and this one alpha comma beta plus beta comma alpha, norm beta comma beta equal norm beta square. So this one is equation 1. After that you can take norm alpha minus beta whole square. So here also in place alpha replaced by alpha minus beta. Again you can apply the inner product property. You got norm alpha square minus inner product of alpha comma beta minus beta comma alpha plus norm beta square. The simply here the plus symbols is there, here the negative symbols is there. So now we can these are the like simultaneous equations. Just you can add the 1 plus 2 equations. Why? Because of here LHS plus symbol is there, that's why you can add the plus. After that the negative terms is replaced by negative terms, it is a replacer. Let us see this here the positive terms is there, here the negative terms is there, the both are the cancel. You got 2 alphas and at the same time 2 betas. So that's you can write 2 norm alpha square plus 2 norm beta square. Then you can take 2 is a common. So let us write 2 into norm alpha square plus norm beta square. This is look like as a it can be written as proved by parallelogram law. So let us see geometrical interpretation. So let alpha comma beta be a two vectors in an inner product space. Here means for example, what is a vector means it is you have the magnitude and direction, so automatically geometry is involved. The two vectors in an inner product space V2 of R with the standard inner product defined on it. Suppose alpha comma beta represents the sides AB line and BC line respectively of a parallelogram ABCD. So norm alpha equal to AB and norm beta equal to BC. Also the vector alpha plus beta and alpha minus beta represents diagonals AC line and DB line of ABCD. So norm alpha plus beta, how we can write it is a AC line. Norm alpha minus beta, it is look like as a DB line. It is like diagonal elements, diagonals. So let us see this here. This alpha plus beta means what is that? AC line. Alpha minus beta means what is that? DB line. So by the parallelogram law, alpha plus beta norm whole square plus alpha minus beta norm whole square, this is a minus, it equal to 2 alpha square plus norm beta square. By using parallelogram law, how we can write this one? AC whole square plus DB whole square equal to 2 into AB square plus BC whole square. So that is the sum of the squares of the sides of a parallelogram law is equal to the sum of the squares of its diagonals. So by using parallelogram law, geometric interpretation, it is proved. So let us see distance in an inner product space. Distance means the two points distance means what is the root over first term whole second term minus first term whole square, like the same property, the line distance between line. Let V of f be an inner product space. The distance between the vectors alpha comma beta, the denoted by distance means d of alpha comma beta, is defined by nor alpha minus beta. Here the symbol, the distance of inner product means d of alpha comma beta equal to norm alpha minus beta. Otherwise it can be written as root over alpha minus beta comma alpha minus beta. So let us see one more theorem on this. Inner product space V of f, prove that d of alpha comma beta greater than or equal to 0. The distance alpha comma beta, you can say it is a positive or 0. So otherwise you can show it is a 0, automatically implies alpha equal to beta, you can prove. So then second one is symmetry property. So once you can add the third, alpha comma beta plus distance between beta comma gamma greater than or equal to the distance of alpha comma gamma, third property. Then let us see this. The fourth one is the distance of alpha plus gamma comma beta plus gamma. It can be written as distance of alpha comma beta. So by using this theorem you can prove this 4. Let us see this proof. The distance of alpha comma beta equal to, it means what is the norm alpha minus beta greater than or equal to 0. So norm alpha minus beta, can I write greater than or equal to 0 means can be written as equal to 0. So once you can take the square on both sides, the right side is almost 0. So norm alpha minus beta whole square, it can be written as inner product of alpha minus beta comma alpha minus beta. So why? Because of already know the since product, norm alpha square, it can be written as inner product of alpha comma alpha. By using that the condition alpha minus beta comma alpha minus beta, it can be written as alpha minus beta equal to 0. So once alpha minus beta equal to 0, beta you can shift the right side, it is equal to alpha equal to beta. So the first one is proved. Let us see this, the second one, the distance of alpha comma beta. Again alpha minus beta. Beta, how we can write? Can I write minus 1 into beta minus alpha, whole minus 1 is a common. So after that minus 1 I can write it is like modulus norm beta minus alpha. Already know the property norm A alpha, can I write A into norm alpha? So by the property you can write like this. Modulus minus 1 means, modulus means it is a plus. Plus 1 it is the same multiplication, the same number will come. So then beta minus norm beta minus alpha, it is equal to the distance of beta comma alpha. So let us see this distance of alpha comma beta equal norm alpha minus beta. Distance of beta comma alpha means what is that? Norm beta minus alpha. That second one is proved. Let us see this third one, the distance of alpha comma beta plus the distance of beta comma gamma. So let us this again you can consider alpha minus beta plus the distance of beta comma gamma means what is that? Norm beta minus gamma. So let us add the both terms. You got minus beta plus beta is a cancel, it is nothing but norm alpha minus gamma. Norm alpha minus gamma, by this property it can be written as the distance of alpha comma gamma. So it means the distance of alpha comma beta plus the distance of beta comma gamma greater than or equal to, maybe equal or greater than or equal, distance of alpha comma gamma. The third one is proved. Let us see this, the fourth one, just addition related. The distance of alpha plus gamma, beta plus gamma, it can be written as the minus of symbol. After that minus gamma and this one is a cancel, you got norm alpha minus beta. Norm alpha minus beta means it is distance of alpha comma beta. It is proved. Let us see this one problem. So most in vector calculus, whatever it is, angle between is very important, but here also in a product, let us see this. If alpha is given 418, beta is the 10 minus 3 are two vectors. They said it is a two vectors in R cube. It means what is the three elements is given, that's why you can write 3. Find the angle between alpha and beta. What is the angle between alpha and beta? Inner product of alpha comma beta by norm alpha into norm beta. So here alpha is the given vector. Let us see this. First you can use the inner product of alpha comma beta. So these two vectors you can multiply, you got that minus 20. Okay, let us see this. Here the minus modulus is given minus 20, means it can be written as 20. So after that, norm means what is the root over first term square plus second term square plus third term square. Here the 418 is given 4 square plus 1 square plus 8 square. Okay, at the same time this one also 1 square plus 0 square minus 3 whole square. You got the total value 9 into root 10. So 9 into root 10, it means it can be written as 20 root 10 is given. It is nothing but 2 by 9 in root 10. The simply, for example, the two vectors is given, you can find that angle. It means cos theta equal to it is a1 a2 b1 b2 plus c1 c2 modulus by norm first vector into norm second vector. You can remember this formula. You simplify easily. So any vectors is given. Let us see this. Let us see this one more problem. If V of R is a vector space of polynomials within a product. So before one you can see that only the numbers related, but you can see this polynomials related. Defined by inner product f comma g equal to integration 0 comma t f of t g of t dt. So integration means what is that? Summation. Polynomials means the first term plus second term square up to nth term. Na? So that's why you can write 0 to 1. F of t into g of t dt. F comma g belongs to V. T belongs to 0 to 1. Find inner product of f comma g and norm g for f of x to g of x. The polynomial equation is given. You can solve this equation as like inner product. Inner product f comma g equal to what the given is integration 0 to 1 f of t g of t dt. But here that each and everything is derivative with respect to t independent variable. So but here the polynomial equation is given x. The simple x is replaced by t. So t square plus t minus 4 and the g of x means what is that? T minus 1. Just you can do the multiplication of this entire equation. You got t cube minus 5t plus 4 into dt. After t cube means what is that? Integration t power of 4 by 4 and minus 5 into t square by 2 plus 4 into t. Then you can sub the upper limit and lower limit. So then simplify, you got the 7 by 4 is the answer. So inner product of f comma g equal to what you got? 7 by 4 within the limits 0 to 1. So let us see this. Norm g square equal to what is inner product of g comma g. So let us already g of x is given. Now just you can take the 2 g of t values. It means t minus 1 into t minus 1. Then you can a minus b whole square formula. So after that you can use an int x power of n plus 1 by n plus 1 formula. After you got substitute that upper limit and lower limit, then you got 1 by 3. So then norm g equal to, here the norm g square equal to 1 by 3. So but you need norm g. Norm g equal to what the value is? 1 by root 3. The simple integration in between 0 to 1. Thank you all watching this video. Thank you.